there are two things we have to practice and learn before actually working on the quadratic formula. First thing is simplifying what our problems and our answers are going to look like. So when we have the quadratic formula, that first section, this section 1 through 10, our answers are going to look like this. Sometimes. We'll talk about all that when we get there. But sometimes your answers look like this. When they do, I'm expecting you to simplify them as much as possible. So let's look at number 1. It is essentially one big fraction. So first thing to simplify for number 1 is this radical part, 2 root 45. Simplify that, meaning you need the factor tree for 45. What numbers multiply to get 45? 9 and 5, and then 3 and 3. So what number needs to come out? 3. There was already a 2 on the outside, though. So what is the simplified radical going to be? 6, and then root 5. It still has this 6, and then plus minus, and then over 6. That symbol of plus minus we have talked about. It was one time in class. Does anyone remember what it actually means? Yeah, it means this. There are 2 answers. One where you add the numbers or add it together, and one where you subtract it. So we're going to get to breaking that symbol down in just a few minutes. Like we'll get to a problem where we have to actually go through stuff. Since you didn't have a perfect square, like we still have that square root of 5, we aren't going to actually get to combine everything and make one number. Our answer is going to be a fraction, but there's still something you can simplify. Where to look for simplifying the fraction, it is 3 numbers. 3 numbers all have to tie together, all have to be divisible by the same thing to be able to simplify further. So it's that first number, it's the denominator, and it's whatever's in front of the radical. Are all of those divisible by something?
Yes.
They're all divisible by 6. So divide it all by 6. That's a 1, 1, and 1. So rewrite it after you've reduced all those numbers down. So that would be 1 plus or minus. A 1 in front of the radical you don't have to change. So the square root of 5 is there. Do you have to write a denominator of 1?
No.
So this is your final simplified answer. So that initial step of simplifying the radical, how we got the square root of 45, once that radical is 5 underneath there, never touch the game. It is done. Of 1? Sure. Okay, so let's look at number 2. On number 2, the first thing you tackle is the radical portion of that fraction. If you have 12, how could you simplify the square root of 12? That's 4 and 3, and then that's 2 and 2. So what gets to come out of that? 2. There's already a 3 out there. So what's the new radical going to be?
6 square root.
6 with the square root of 3. It still has the 10 in the front with the plus minus symbol, and then the denominator is still 4. The 3 parts have to all be cohesive, like they have to all go together. 10, 6, and 4. Are all of those divisible by something? 2. So now rewrite it after you divided all of those parts by 2. So that's 5 plus or minus 3 root 3 over 2. Okay, so look at number 5. So the one below the one we just did. 4 square root of 7. Can you simplify the square root of 7?
No.
No, because that's your 7 times 1. So for this problem, just look at those 3 numbers that we were just talking about. The number in the front, the denominator, and in front of the radical. Can all those be divided by something?
Yes.
They're all divisible by 2. So that would be a 3, this would be a 2, and that would be a 1. So 1 plus or minus 2 square root of 7 over 3. Now let's look at number 8, so the one now below that. And then, so finishing out that column. On number 8, square root of 18. Can you simplify the square root of 18?
Yeah.
So we've got 18. That would be 9 and 2, and then 3 and 3. So what gets to come out?
3.
A 3. There's already a 5 on the outside.
15.
So that's 15, and what's left under the radical? And then we have the 7 plus or minus, and then 14. 3 numbers have to be cohesive to simplify further. It's the number in front, it's the denominator, and it's the number in front of the radical. Are all 3 of those numbers divisible by something? Then you can't do anything else after simplifying the radicals. That is your answer. It has to be those 3 spots that simplify to something. If one of them doesn't work, so the number 15 is what screws it up, right? So you have to make sure all 3 have to match to be able to simplify anything. Questions? Let's do number 4. Number 4, square root of 121.
11.
That is a perfect square. 121 is a perfect square. The square root of 121 is 11. So 3 plus or minus, there is no longer a square root. We just have this 11 over 4. Now, since we had a perfect square, you don't just leave your answer like that. What you do is now this comes in. This plus or minus. This means we can actually get 2 regular number answers. Because all of these answers that we've had before, they technically are 2 answers. They're just like complex or like complicated looking numbers. This problem number 4, we can get 2 like normal looking answers without radicals. How we get them, you do it twice. This plus minus symbol literally means you have one answer that is 3 plus 11 divided by 4, and the other one is 3 minus 11 divided by 4. So for that top one, 3 plus 11 is 14. So 14 over 4,
7 over 2.
which is 7 over 2. And then the bottom one, 3 minus 11 is negative 8. But negative 8 divided by 4, negative 2. So that's what that plus minus symbol means. It literally is adding and subtracting the 2 things together. It's just if there's still a radical there, you can't add them together or subtract them because radicals are like terms, like x's and y's. You can't just combine a constant and something with a radical. They can just add together. So look at number 10. Look at number 10. Simplify the radical. What's the square root of 144? 12. So it is another problem like what we just did. 2 plus or minus 12 over 5. Which means you have 2 answers to get. One comes from 2 plus 12 over 5, and the other is 2 minus 12 over 5 to get our 2 answers. 2 plus 12 over 5. So 2 plus 12 is 14. 14 over 5 is still 14 over 5. Then 2 minus 12 over 5. 2 minus 12 is negative 10. Negative 10 divided by 5. Negative 2. Okay. That is one tool when it comes to quadratic formula. The other tool or other thing you have to be able to know is how to identify A, B, and C. We have done that already. If we're talking about A, B, and C, do you know what form it has to be in? Standard form, which is the ax squared plus bx plus c, and it either has to equal y or it has to equal 0. It's y if it's talking about the graph, it's 0 if it's just a regular equation. But one side has to be either just y or 0. So that first one, is that in standard form? Yes? What's the A value then?
X squared.
1. What's the B value? And the C value? What else is in standard form? The one right below it? Yeah. The one below is in standard form. What's the A value? What's the B value? What's the C value? 0. The constant is 0. Anything else in standard form?
The one.
The one even below that? Okay. What's the A value for that one? What's there? What's the B value? And the C value? Anything else in standard form? So how could you turn something into standard form? Just multiply it all out. We've been doing that a lot, so I'm gonna have to skip the rest of those. Most times I'm gonna give it to you in standard form anyway. But so go to the next part. We have now talked about the 2 critical things to be able to successfully get our quadratic formula. Alright, quadratic formula. This is it. The purpose of the quadratic formula. Let's go to this problem. Example A. So far, if I had asked you to solve this, what do we do to solve it? Factor it. Okay. There's a number in front of x squared, so that has to multiply with a constant. So that is -6. We need numbers that multiply to give you -6. But what else do they have to do? Add up to -3. Numbers that multiply to give you 6 are 1 and 6 and 2 and 3. Is there a combination of those numbers that's going to add up to -3? No. So previously, what we have done is, okay, well, it doesn't factor. Let's put it in the calculator. Maybe we can find stuff in the calculator. So if you go to the calculator now, and you put it in the graph, well, here it is on the graph. Do you see it cross the x-axis? Yeah, you can do it. You can just look at the board. Yeah, it's crossing the x-axis. Are they nice numbers? They are decimals. Has anyone taken a guess at what those decimals are?
1.5 and 0.4.
-0.5-ish and 2 point something-ish. We don't know exact. What we're doing, the quadratic formula is here because it's the problem that you can't factor. It's the problem that, like, you know there are x-intercepts, you know there are answers, but factoring our only way that we've learned so far isn't possible. That's why this exists. It is on your formula chart. I will give you the great pleasure of listening to me sing it as a song. When I was in Alpha 1, I was forced to sing this song back to my teacher for a grade. I will not make you do it, but you can hear it. It's in a tune of Pop Goes the Weasel. So, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. You're welcome. Thank you. Thank you. All right. So when you're plugging in what we just did on the front page, is that problem that we attempted to factor coded, is that in standard form?
Yeah.
What's the A value? What's the B value?
-3.
What's the C value? It is literally plugging those numbers in. This is your A value, this is your B value, this is your C value. It is plugging those numbers in up here in the corresponding spots. So x is equal to -b, so it's a negative in the formula, and then our b value is -3. Plus or minus the square root of b squared. This is where you need to be careful. We are squaring. There's going to be a lot of times that your b value is negative. If you don't use parentheses, you're going to get the wrong stuff. So that -3 is in parentheses before you square it. Minus 4ac all over 2a. So it is plugging numbers into their corresponding parts. Now from here, it breaks it up. So I like to view the quadratic formula in like 3 little sections. The first section is what's in front of the plus minus. So it's a double negative. How could you simplify double negative? It's just a positive. The denominator, it's 2 times your a value. So what's 2 times 2?
4.
Okay. And then the third section is what's under the radical. In your calculator, type what is under the radical, under that square root symbol. Not the actual square root symbol, but the -3 squared minus 4 times 2 times -3. Or you can do it by hand. Yeah, for sure. You should be getting 33 under the radical. And now this problem looks just like the things we were simplifying before. Can you simplify the square root of 33? Well, what numbers look 11 and 3? Can you get pairs out of that? And then if you go to try to simplify like what we were doing on the front of the paper, the 3, the 4, and there's a 1 in front of the radical, can you simplify anything there? This is your final answer. So we're gonna do the next one. We're not simplifying that first one anymore. That's it. On the next one, example B, is that in standard form?
Yes.
What's the A value? What's the B value? What's the C value? Okay. So x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So then take it section by section. In front of the plus minus, we have a double negative. So since it's a double negative, it'll be positive. And then we got the plus minus. The denominator, 2 times 2 is 4. I saved under the radical for my last little section. All the other stuff I can do mentally. But now under the radical, that's -9 squared minus 4 times 2 times -5. You can do it by hand, or you can just put what's underneath the symbol in your calculator. Don't put the symbol in the calculator, put what's underneath it.
121.
You should be getting 121. What's underneath the radical symbol? So the -9 squared minus 4 times 2. Uh-huh. Okay. Well then, can you simplify the square root of 121? What is that? 11. So guess what this means? This means we're going to have 2 like regular normal answers. Which means going back to the original problem that we had, that could have factored. You could have just factored to solve that problem. The ones that are not factorable are when you have the answers with the radical still. But if you go through and you solve it and the radical disappears, that could have just been a regular problem that could have factored like normal. First answer, 9 plus 11 divided by 4. 9 plus 11 is 20 divided by 4. And then the denominator, 9 minus 11 is -2. But -2 divided by 4 would equal what? -1. So what this means, your graph, you would have x-intercepts at 5 and -1/2. This would have been a normal problem that you could have solved yesterday. Like you would have no problem with it. So how this is now helpful, those of you that have struggled with factoring and struggled and struggled and struggled, this is now an option. Now, I do think it takes a long time to plug things into the quadratic formula. There's like places where you can make mistakes, so it's a little bit more time consuming, but it's a solvable problem now. So those of y'all that were leaving things blank, you can now like get something, right? So it's just another way to solve a quadratic that we've already been doing for the past 4 weeks. How long is that for? Like for forever. Okay. So go down now to the bottom. We're going to do number 1 together. On number 1, is that in standard form?
No. 20.
Is one side 0 or y? Okay, so subtract 3x, so that's 4x squared minus 3x minus 1 equals 0. So now we need the a, b, and c value. What's the a value?
4.
What's the b value?
Negative.
And then the c value?
Negative 1.
-1. So plugging all of that in now, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So instead of breaking this one down and simplifying it like the problem we just did above, I'm going to have us go straight into this direction. Say, it says radical form. I'm going to have to ignore that part. We're just going to write it rounding to the nearest 10 or 100. What this means for you guys, you don't have to go through simplifying steps. This is now 100% calculated. 100%. I'm going to show you some tricks and some shortcuts and something that is helpful for the calculator, but like we don't have to simplify a single thing. You can type it as is in the calculator, but you can't type the plus or minus part. So in your calculator, first thing to make sure everyone knows how to do you know how to make a fraction? How? Control divide. Blank fraction gets you set up for success. Oh, that's fine. And then we've got, I'm typing it exactly like we wrote it on the paper. It's a double -3. I know you could simplify it if you want to, but I just like to type it as exactly as it is. You can't type the plus minus, so we're going to have to do it once with the plus sign and then just do it again with the minus sign. It's going to be a 2-step process. But then we have our square root symbol. And then -3 in parentheses, then you square it, minus 4ac over 2. Okay. Press enter when you have it, like mine. What's the answer? 1. Therefore, you know what that means? When you get a regular answer, so the number 1, the answer of 3/4, something that is just a normal looking answer, that could have been factored. We're now going to do the exact same thing, because remember, our formula is plus or minus. So we now need to do this exact same thing, but instead of this plus sign here, we need the minus sign. I'm going to show you a shortcut if you did not already know this. You do not need to retype it all in. Please do not. That is a big waste of time. Press the up arrow twice. It highlights that big old thing that we typed in. Press enter. It copy pastes. So now just go back into that big thing, and that plus sign, just change it to a minus sign. So delete it, make it a minus sign. -1/4 is the other answer. So if you were graphing it, your y or your x-intercept to get 1 and -1/4, you could have just factored that problem from the very beginning instead of doing all the plug-in things. All right, let's look at number 3, so the one that's below it. Let's practice doing it all in the calculator again. So the directions say round to the nearest 100. That means you're plugging everything into the calculator. It will do all the work for you. So you need to just put it into standard form and then plug things in appropriately. On number 3, is that in standard form? Try again. Oh, why not?
Wait, you just like go up 2 and then
Press enter. Just press enter. Okay. Making one side 0. What is the A value?
6,
What is the B value?
-3.
And C value is -5. Quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Again, we're going to do just the calculator version of this one. So not a simplified radical, straight up, you are allowed to give me whatever decimal the answer is. Which means you go to your calculator, type everything that I just wrote in your calculator, once with the plus sign, copy it, do the other minus sign. Okay. We're going to go back, so we're going to do number 2 again, or do number 2. On number 2, I wanted to go back to the simplified version. So this is where just be careful with directions, whether it says round to the nearest hundredth or if it says write your answer as a simplified radical. I'm going to have us do number 2 with the simplified version again. Is number 2 in standard form?
Yes.
What's the A value? What's the B value? -1, what's the C value? So back to the simplified version, then x equals -b plus or minus the square root of b squared minus 4ac all over 2a. When it's the simplified way to solve it, break it into the 3 different parts. The first part is what's in front of the plus or minus, so that would just be a 1. Then we got plus or minus, the denominator is 6. And then don't type the square root symbol, type what's underneath it into your calculator to get what goes underneath the radical. Because if you type the radical, you won't be able to simplify it. Right, so you have to have what's underneath the radical, therefore we go through the simplifying steps as needed.
45. No. 23.
You should be getting -23.
Oh, no.
Okay. So now I need you to all do, if you were typing things in your calculator, stop whatever you were typing. I need everyone to type in the square root of -23. You should all be getting an error message that pops up. I want y'all to see what that looks like. That error message, it says non-real calculations. What that means is that your answer is that there is no real solution or no real roots. So what would that mean about a graph? It would be a graph that looked like this, or looked like that, or looked like this. It'd be one of those graphs that if you don't see it crossing the x-axis. The reason that the answer, think about a square root. How do you get the square root of something? Well, it's what number times itself gives you that. How do you get a number that multiplies by itself to give you a negative number? You can't, because a negative times negative is positive, and a positive times positive is positive. So you can't have those negatives under the radical. So if you ever have a negative under a radical, no real roots, no real solutions. That's it. And it just means on the graph. Like we've seen that graph before, but now that's what it looks like when we go through quadratic formula. Yeah. Okay, go to the next page. Let's take a look at number 2. Is number 2 in standard form? Yes? Okay. What's the A value? What's the B value?
4.
And the C value?
4.
We're going to write this one as a simplified radical. So we're going to go back to the simplified version. which means you're not just plugging the whole thing in the calculator. So negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yes.
Break it down those three different parts. We've got a negative 4 in the front, plus minus, a 2 is in the denominator. Now you just have to figure out what will be underneath that radical. All right, so it is 12 under the radical. If I'm asking you to simplify it, now we go back to the very beginning of our notes. Can you simplify the square root of 12? Yes. So we need to. Numbers that look like 12, 4 and 3, 6 and 2, whatever. We got 2 and 2 here. So what would the square root of 12 turn into?
2 square root of 3.
2 with the square root of 3. We've got the plus minus symbol, the negative 4 still, and the 2. Final step, you've got 3 numbers to check. Are these 3 things divisible by the same number?
Yeah.
2. You can divide it all by 2. So that would be a negative 2, a 1, and a 1. So your final answer would be this. That would be an example of like the most work for a quadratic formula problem.